Hello, I'm Adarsh Tyagi from ECE branch.
I am Shivam Kumar of COE branch.
Hi, my name is Shivam Bareja. I'm a student of Electronics and Communication Engineering.
Hi, I'm Saumya Vohra from EC branch.
Hi, I'm Nikhil Varandani from ENC branch, and we are Team Autocop presenting to you the smart, secure, and intelligent home automation system.
So in our home automation system, we are using the ESP8266 or the Node MCU as the microcontroller and Raspberry Pi 3B Plus as the microprocessor. The Node MCU controls the lighting system of our home automation system. It also has a MQ2 smoke sensor attached to it with a buzzer on it. The microprocessor, namely the Raspberry Pi, is there for facial recognition and verification of the personality, whether the person is known or unknown. Now we have uploaded this project on a web-based user interface. We made this web-based user interface to control the home automation system. We have the whole control of the home automation system on the website.
The first code is recognize.py for face recognition. First of all, we have imported some libraries in this code which we will need. The face recognition library is used to recognize the face. IMUtils is used for resizing the image. Pickle is used to pass the face encodings. CV2 for color changing functions of image and to display the images. OS is used to access the file. URL lib.request to get images from phone. NumPy is used to make changes in images. RPI.gpio for turning on the LED. The cascade path face is used to access har cascade file to detect face. Now we have defined the cascade classifiers and then we have loaded in the data from Pickle. After that, at line 18, we have defined some pins of Raspberry Pi and set its mode and turned off the warnings. We have set pin 21 as the output. Then we started a while loop in which we took the image path to take images from phone and converted it to NumPy array. And then it is converted into an image of CV2 and then to the grayscale. This image is then passed to face recognition and it is again converted to RGB to display it. Now the image is encoded into encoding variable and then we see an empty array called names. Using a for loop, it will pass through all encodings and it will check if there is any match. It will compare the encodings of image with the encodings that we have saved in that file. Then the name will be set to unknown. If match is found, it will be assigned a name and the new name will be appended in the names array. Then an if statement is executed. If the name is unknown and if t variable is greater than 20, then the lights will be turned off and 1 will be subtracted from t. Otherwise, t will be added to 2 so that it will turn on quickly and turn off slowly. But if the person is unknown, then the light will go in off mode directly. Then we see rectangles will be made in the for loop and image will be shown. Then an if statement is implemented. If the video is on and we press Q, then it will turn off automatically. The second code is make encoding, which is used for training the images. The libraries explained in the other code are imported again. This code will go through the path of image and the name of the folder is the name of the person whose images are to be trained. Then one by one, it will read the images and convert them to RGB. Then using face recognition, it will make a box around the face. This box contains all encodings which will be recorded and saved in an array. And then finally, they will be saved in a file named facein.
Talking about the door security system, we have used Raspberry that is connected to my PC, that is connected to an app that is IP webcam, and we haven't used Pi camera. We could have used that as well, and we have used a green light here that will glow when it detects a person that is known to the system. We have used the har cascade technology and you can see my name is getting displayed once I show up in the camera and the green light is also glowing, right? And it will glow for a moment and it will go off once it has detected the known person, as you can see. And if the person is unknown, it won't glow. That means that the system is not able to identify the person. And if you have to add a new user or a new person to the system, you will simply have to click some photos through the system's camera and save it into a folder and update the program. And once the program is updated, you can directly see the person's name on his face once it comes in front of the camera. So in here it is the Node MCU code that we have used. We have used various digital pins as well as analog pins, and you can see that the threshold value of the MQ2 smoke sensor is initialized as 650, and we have assigned an analog pin to the smoke sensor as well. And now, first of all, we are establishing a connection with the Wi-Fi hotspot so that the node MCU is connected. Once the node MCU is connected, we are able to access the user interface through that. And even if we are not able to establish a connection, the node MCU will still work. The MQ2 sensor will still work there. And coming down, we have written the HTML code for the user interface, and we are checking app states on or off. We can control the apps from here using the buttons that we have made here. And coming down, we have disconnected the connection in the end. So that is all for the node MCU code. So here we are testing our MQ2 sensor, and as you can see, I have lit up a dhoop, and basically we have put 650 as the value of that is the threshold value, and after that the buzzer will beep, and we have our user interface here. Basically those two appliances are on right now, so you can see that we have two lights on the relay that we can control the appliances through. And the other one, MQ sensor, is basically saying all good here because right now it is not detecting the smoke that is more than the threshold value. Once it goes above the threshold value, the buzzer will beep and the value will change here. So as you can see that the buzzer sounded and alert smoke detector is on the screen. So that was all about the home automation system that we designed. I really hope that you liked it, and signing off, Team Autocop.